Hello, welcome to lesson 6.5. In this lesson, we're going to interpret p-values, and I mean, hopefully you're beginning to see what we've been talking about all along. You've been watching all the videos. We've been always saying, I wonder if I have enough weird enough idea or small enough, rare enough occurrence to say this isn't so. Well, that's the idea of a p-value, essentially. We've been building to this all semester. So we're going to be talking about how we do what's called significance testing. It allows us to make a decision about a hypothesis, those null and alternate. Once we set those up, then we're going to do some kind of experiment or gather some kind of data, and then use that what's called a p-value to make the decision. We're going to calculate that p-value and use that to help us make an interpretation. Okay. So our essential knowledge, we're going to have that null and that alternative hypothesis. And we're going to come up with what's called a z-test. And there will be a formula for that. We're actually going to end up going through that. Here's the formula for it that you'll use to get the p-value that you'll use to make your decision. Okay. So when you're making that, you'll, and don't worry, we're still going to be doing all the same, or we're going to actually end up using the calculator to do the testing. Okay. All these formulas are not necessarily on the, they don't need to necessarily be on the formula sheet, but you do need to know when to use what type of test. Okay. And the conditions are still there. So the p-value is the probability of us. So what we're going to do is we're set up those null alternative like we talked about the last, and we're going to gather some data. We're going to do something. We're going to survey. We're going to measure, do something, and we're going to then calculate the odds or the probability of getting results like we got from our experiment if what we assumed in the null hypothesis was true. So we're going to assume the p-value from the null, and if that's true, what was the probability of us getting what we got in our results? If that p-value falls within a certain threshold, then we'll be able to make a decision. Okay. Wherever it falls, how it falls, we'll make a decision. So if we're trying to do, when we're doing the test where we had greater than or less than, we're looking for, so if we want it to be greater than, we get something that's significantly above, that's when we would reject it. If we're looking for below, it would be on the left side. And if it's not equal to, it would be on either side. So we're going to look at visuals of that, and I think it'll make more sense then. All right. So when we're trying to prove something is really higher, we're looking for an area in the rejection up here. So what we're trying to do is disprove that null. So the alternative is what we're trying to find. So we want something to be high. That's called an upper tail test or a right tail test. If we want to show something is low or less than a certain threshold, we would do a left side or a lower tail test. And then remember back to the skills where we weren't sure, it could be on either side, greater than or less than. But the idea is we want the small end depending on which direction we're going to be testing. So here's an example. Our null hypothesis is that the p-value would be less than or equal to 0.2, and then the alternative would be greater than 2. So what we want to do is that we want to right tail. We were trying to show the alternative. We'd like to we're trying to think the alternative is what is happening. So the picture would be here, a rejection region if we get something significantly higher than 0.2. So if we are trying to show that it's greater than 0.2 and we get 0.21, that may not be significantly higher enough, because it could happen by chance. We want something that occurs, and generally this will often be only 5%. Remember, we're going to keep using 95. If they, I mean, it may vary. The problem may specify in certain conditions, certainly have different thresholds, but the generally assumed one is 5%. If we have one where we're trying to show that something is equal to 50% or 0.5, or we're not sure which way, like the Skittles, our rejection regions on either side. So when we do that, we're going to have on both sides. And so if we have 5% rejection region, something that happens only 5% of the time is something we've deemed as being unusual. So that would mean we have 2.5% on each side, or 0.25. So this is what it would look like when we're not sure which way it would go. If it's a right tail or left tail, we'd be looking at the rejection region. So what we're going to do is we're going to gather our experimental data. We're going to figure out the probability of it based on the null being true. And if it falls in one of those regions, then we can reject the null and we'll be left with the alternative. Okay. So what we're going to be doing is we're going to get this p-value. This is what we're going to get here. This is the results of our experiment. Okay. If we get something that happens in less than this number, and 0.0187 is less than 0.05, then it's smaller. You can be confident you can reject your null. Okay, remember we have the two alternatives: you reject your null, or you fail to reject your null. And that's it. We're just going to be estimating those values from a simulation. There might be some graphics stuff for you to look at, and that is the idea of the p-value.